All right, we're going to talk about irrigation. I figured that I could either spend weekends after weekends driving around out in the country trying to find a field that's currently being irrigated, but that could take forever because it's kind of a slow time in agriculture right now. So what I figured I would do is just make some soil and then kind of make a scale model for you of the different types of irrigation, try to explain some things. So let's make some soil. What I got here to start off with, and I just got this from the courtyard of the school, I've got this sort of light orange colored clay with like gray specks in it. I've got this darker gray clay here, and this is from some just brick dust that we're going to use to simulate sand. Now, the darker colors is from higher up in the soil profile. So when you look at soils, you got an organic layer, an O layer, which is just dead leaves and sticks and stuff like that on the very top. Then you have A, which is your zone of decomposition, where a lot of this stuff is breaking down. That's where our soil organisms are. That's all of our earthworms, ants and grub worms, all sorts of goodies. And things are decomposing, and that's why it has this darker black color. And what is supposed to happen is that the materials, the chemicals that are created as things decompose, phosphorus, nitrogen, and so on, salts, etc., are supposed to leach down through the O layer and be deposited in the B layer. The B layer, the fact that it doesn't have that black color suggests that it does not have a ton of oxygen exposure for decomposition. This is heavier, it's very, very tightly compact, and this is looser, a little easier to break up and everything. And that's because this has been 2 or 3 feet down at least, and it's had all this soil pressing onto it for probably millennia, okay? Back when this was all fields and well, not even before mankind, when this was all short grass prairie and post oak savanna. And so that's how this soil has developed. There's probably a ton of phosphorus in this because it's a zone of deposition. There's probably more salts in this too, because salt's naturally occurring as things weather and erode and everything else. Salt's natural on Earth, and it erodes, right? It goes where the water goes, and that's why the ocean is salty. Eventually all the water ends up in the ocean, right? Well, it picks up salt from the Earth, and that's how the ocean ends up salty. Consequently, our subsoils can have some salt in them as well, and that's going to come in later when we talk about salinization. But first, let's make some soil. Okay, here we are. We have not a very good soil, but we're going to call this our soil. Okay, it's a mixture of rock and a couple of different types of clay from various subsoils or from soil horizons, and about half of it is B horizon or subsoil, and the rest is A horizon, so not organic matter. In a normal farm, you would actually have a lot of organic matter, and then some like construction dust, because that's what I had here at school. So this is where we're going to start. Now, as you can see, it appears to have been, excuse me, tilled. It's all broken up. That giant disc machine comes through there and stirs everything up, and they go round and round and round and breaks it all up, and you get kind of aggregates like this, okay, which is what I showed you in the actual fields when I took you out into an agricultural field. So it looks a lot like this. Now, the first type of irrigation that we're going to look at is drip irrigation. And we're going to start here because it is the most efficient use of water. Listen carefully. Drip irrigation is the most efficient use of water, and it saves topsoil more than any other type of irrigation. We're going to have less erosion and less water loss. So I've got a bucket of water here. I've got a cup with holes in the bottom of it, and this is going to create our drip. So I've got a fast drip, and it's going to sit right down on the soil, real close to the soil. That's very important. The further it gets away, the more contact with the air we have, then you get more erosion. In drip irrigation, you put the drip right down on the soil in contact or just above it, and that's dripping. You You see, I don't know if you can see it dripping there. Okay, but it's dripping right down onto the soil, and it's not really in contact with the air. It goes directly to the soil, from the source to the soil directly, and it's low velocity. That's important. I told you that when we first started talking about erosion versus weathering, and then again when we talked about soils. As the velocity of the water goes up, erosion goes up, okay? And there is hardly any velocity to this at all. And so that's why we're not getting a lot of erosion. Now, the next thing we're going to talk about is spray irrigation. Spray irrigation is extremely common here in the United States, and you've seen the big thing. There's these arches that go out across a field, and then they rotate. If you've ever been on an airplane, you look down and you can see these circles. Those are irrigation. This is the reason it's done like that in a circle is because there's a center post where water comes up and then it goes around to the sprayer and it goes around in a circle. Those are very high up. You've probably never seen one up close in person unless you own a farm. Otherwise, you probably haven't seen that. So they're really high. The spray starts somewhere between 4 and about 8 feet up. This is going to simulate my spray irrigation. So I've got it. Now I'm only going to be, whatever, I'm pretty short, so only 3 feet away. And it's going to be sprayed under pressure. And you can see, you may not be able to see on camera all the water, maybe on my hand. I'm spraying the water, but look, there's water and soil particles being knocked off and moved about, okay? You see it on my hand. You can even see this on the side of your house after it rains. There's dirt up all over on the side of your house after it rains because the water has hit with velocity and it is disassociated little tiny pieces, right? And those are removed and separated from the soil. That's what's going to run off, okay? It's going to land in little streams and creeks and rills and everything else, and it's off it goes. As this high pressure water hits it, and the more I do it, I'm getting even more dirt all over my hands. Okay, that's the dirt that's going to run off. Every time there's an irrigation, every time that sprayer goes through and sprays, then it's going to disassociate some topsoil, and that's going to run off as the watering keeps going. And then the next time it rains, those little tiny particles are already loose, and so off they go. Now, spray irrigation is not the cheapest, but drip irrigation is the most expensive because you have to have something like a soaker hose, which I'm sure you've seen these at Lowe's, Home Depot, stuff like these are residential, okay? Now in an agricultural setup, they look different, and obviously they're significantly larger, but this is a drip hose, and this is porous, and you run water through it and it drips. But that takes a whole lot of capital investment, okay? Which means the farmer has to buy a whole lot of materials to make this happen. So it is the most efficient, it saves the most topsoil, but it's most expensive. Somewhere in the middle is the spray. Now, the spray does lose a lot from evaporation because there's so much contact with the air, and it makes a relatively fine mist. And that mist, the smaller the water particles are, the easier it is for it to evaporate, right? And the further away it is, the easier it is to evaporate. So we're losing some water from evaporation, and we're losing some topsoil as well.